So it is sometimes useful to combine technical studies and economic studies, and this is what we have been doing in the SAIL project as well. And I will be telling about methods that we have learned in my team more generally, but also especially I will be using the topics of SAIL project, especially the network of information, the information-centric networking as an example where we have been using our toolbox of methods. Firstly, everybody is familiar with the hourglass model, the protocols of higher layers, the application layer protocols, and the lower layer protocols, and we have learned that there is something in between, something narrow, the TCP/IP protocols in the case of internet. But you can use actually the same hourglass model to describe the business aspect of internet. This is of course a highly simplistic figure, but it basically says that most of the revenues are collected from users on the higher layer protocols, on the applications. So users understand applications and content, and they understand that it's useful, they need it. It's obvious that they pay for that part, but it's more difficult to understand the enablers, the basics, like the basic transmission services and connectivity services and so on. And this situation is even more complicated because a big amount of costs happen to be concentrated on the lower layers. Especially access network is highly expensive and requires big investments. And lately, especially the mobile networks are facing heavy investments, and the question is that how to balance this upstairs, the revenues coming to applications and the investment costs downstairs for the network. Any economic system somehow needs to find a sustainable balance over time. You can be in unbalance for a short period of time, so you can sell below costs, or you can rip off customers and take unreasonable profits for a short period of time, but that fun doesn't continue long typically. So somebody intervenes. The competition gets interested, the competition gets tougher if you make higher profits, or the regulator gets angry and changes the rules so that your profit opportunity disappears. So you can find some kind of monopolistic pockets typically for short periods of time, but don't count on those for long term. So this raises basic questions, this simplistic picture about how to move money from upstairs to downstairs in a sustainable manner in cases where there is imbalance and sufficient investments cannot be done. This argument, as you may know, is continuous argument between operators and content providers, and has always also between network operators and the regulators. So those of you who have involved in these discussions know that network operators always argue that the tariffs and the revenues are not sufficient for the important investments forthcoming in the networks, and the regulators are negotiating in the other direction by arguing that consumers need low prices and competition must be increased to get prices lower and so on. This one name for this basic argument when we discuss about content and network functions is the net neutrality debate. That has been very hot in the US over several years already, but in Europe it's more or less probably starting, or for various reasons it has not been very active. This comes back to the question that what can what can the network operators know about the applications and content? Comes back to the questions about deep packet inspection and so on. There are all kinds of debates and tussles ongoing about these topics, and network operators are testing the laws, and content providers are testing the laws and so on, limits of the law. There is one interesting aspect for those who are working on in the middle part of this hourglass, that there are no huge revenues and no huge costs. There are costs and revenues, of course, but compared to upstairs and downstairs in the middle, this is more limited. And as a researcher, you may have noticed that it's sometimes difficult to argue research funding, for instance, based on the big revenues of applications, because that's somebody else who is researching that. Or the big investments who are studied by radio access network people and so on. So often you are then arguing in the middle layers that it's the threat of scalability or it's the threat of misuse, terrorists and so on, or whatever, so that the middle layers stop working for some reason. So it's not the big income or big revenue or big costs and investments. It's more the overall functionality. So the middle part is gluing together the whole thing. One question is that is this somehow changing this basic model? And at least I have not seen much other changes in the fundamentals than the cost of energy, because the transmission speeds are going up, and it seems very difficult to get the optical functionality to reach the processing side. So the processing in routers and other active network elements, the processing takes more and more energy, and that increases the cost and all kinds of troubles. So it seems that the relative cost of let's say, the narrow waist of the hourglass, the relative cost is increasing, but not very rapidly, because the same energy problems appear also on applications, on data centers, on servers, and they appear on devices and access networks as well. So this is more or less, I'm using this slide actually to describe the research of my team. So, but here I'm using this slide slightly modified as the list of contents for my talk. You can see on the left-hand side the research topics based on technologies. So there are people in my techno-economic or network economics research team who have software background, mobile services, some software computer science background. Then there are protocol IETF-oriented people, Internet Core related people, and then radio access people who have radio protocol competencies. And all of these are moving, extending their competencies towards economics, trying to not maybe become real economists, but to understand and be able to discuss efficiently with real economists and so on. So we are engineers, but trying to learn something about economics. And today I'm focusing on this Internet Core. But if you remember the previous slide, it is quite valuable in economic studies to understand the upstairs and downstairs also in the hourglass model. Because if you focus narrowly, fully on your economic studies, on the narrow waist, on TCP/IP and close to it, it might not be for some problems the right level of abstraction. You might need to address the revenues of applications, or you might need to address the investments deeper in the network technologies, the access network technologies, to understand how the economic system works. So therefore I see that this combination is useful to expand from IETF and Internet Core related questions to little bit lower towards radio access and higher to mobile services. As you can see, we are very much mobile internet focused. So you can see this overall approach. You need some focus anyway, because as you can figure out, this is quite a broad focus otherwise. But if you squeeze it to mobile internet, then you actually get interesting focus, also substance-wide. Of course, there is a slight problem in this focusing, because it seems that everything will be gradually mobile internet. So there is less and less non-mobile internet from users' viewpoint. Then you can see research methods, and here also I'm using red color to list the topics that I will touch today. So we are using qualitative methods and quantitative methods. Typically, in a new problem, we start from more qualitative methods and then go deeper into quantitative ones. And I will be talking today about industry scenario construction or scenario planning as one of the methods under that heading is called. And then value network analysis, value network configurations. And let's see how much we have time. I will touch system dynamics and then maybe techno-economic modeling. About these methods, we have found that these qualitative methods are very good, for instance, in the beginning of a new project, like a SAIL project now that we are having. Or they are quite useful also, at least for my purposes, when there is a new PhD student starting and you need to get the new research path towards a new PhD thesis up and running fast. So you can use a qualitative method that encourages the researcher to go and discuss with the best experts, to find the right experts on the topic area, to look at the top-down, holistically, the problem area, and find the right prior art literature and so on, and structure all of that to build some kind of stick figure model about the whole problem area rapidly. And the same applies to value network configurations and value network analysis. That also is useful in the beginning. It also helps to create hypotheses, research hypotheses and so on. And then you go deeper into quantitative methods gradually. Then this gives an idea about the economic theories that we are using, but I don't go into, this is not today's topic, so I will not much touch these topics. It's a broad list of topics anyway. One question here that would be useful to understand that how many people in the audience have taken courses in economics. So simple question, you have taken at least one economics course during your university studies. Please raise your hand. Okay, so there maybe half of the audience, which means that the other half has succeeded to avoid this stuff. You're trying to encourage me. Okay, so let's move to the first topic, first method. So the method is called scenario planning method, and I'm using a case here to describe mainly the case. Hopefully is interesting to you, but the main focus is in the method to understand something about the method. This kind of qualitative method actually is relatively straightforward to use, so that you can quite easily apply it in your own research topic if you so wish. So content delivery scenarios, which is close to related to network of information in the SAIL project. And as you can see, this is mostly based on a paper that will be presented soon in International Telecom Society Europe, actually in 2-3 weeks. Okay, the font is a bit small and the slide is busy, but this kind of describes the general steps of the method. I don't go through all the nitty-gritty here. I just want to show you kind of the main points. So this is basically a simple recipe for you just go through the steps, and consultants do this kind of work in big companies, especially in strategy efforts in bigger companies, but then they skip things and do it kind of fast, quick and dirty. If you do this kind of research academically, then you focus on systematic approach and data collection and so on, and you get some kind of science out of that. Okay, first of all, you define the research topic, the issue that you want to study. There are important things like time frame. If you are looking into the future, you want to describe somehow the future in your topic area. You want to define scenarios that are relevant and interesting. So this is not just any kind of scenarios. This should be the right scenarios. What will be the right scenarios about the future? It's not that we are telling the future. We are looking for interesting possible futures that make sense, that are possible, they make sense. And the purpose is somehow to span the possible futures in a way that you know that these corners define the area of possible futures. And the real future must be somehow in the middle of these poles that you kind of define. Typically you create like 4 scenarios, and they define the edges, the extremes. You exaggerate a little bit to the limit of possibility, each scenario. And then you should know that the reality is somewhere between these scenarios. Okay, so first you identify the major stakeholders, roles and actors. We'll come back to that part a little bit with the example. By the way, the time frame in the first step, the time frame is very important. So depending, the whole setup might change if you define that you study a 5-year period compared to 10-year period or 1-year period. So you have to be careful and accurate in what time frame you are planning for. Okay, then you are looking for the main forces about the future, or the forces that are molding the future somehow. And this is typically a brainstorming exercise or based on interviews. And you list a lot of candidates for the major forces. And what you are looking for, you are looking at forces and phenomena that are highly probable, that the probability of happening is high. And those are, when you identify those, you call them trends. And the trends are typically like 90% likely to happen, or 95%. Nothing is 100%. It's kind of conditional probabilities that we are talking about here. And so you can pick up things like internet will be growing. The traffic volume in internet is likely to grow. And you can probably identify that most of the experts that you discuss with, they agree. So experts agree on this, and then you make the assumption that this is 90% true, that internet traffic will grow. And the similar example is the number of users in internet globally. So you probably will find out when you discuss with people that, okay, the top experts, most of them probably believe that number of users is growing and not decreasing. Okay, you know quite a lot already about the future if you list this kind of things. And if you get the surprisingly powerful feeling when you list a sufficient amount of things. You actually feel that, okay, I understand about the future. But then the trouble comes when you get forces that are uncertain. And these are actually more important. So you're actually looking for uncertainties. And uncertainties are those things where experts fundamentally disagree. You discuss with the best experts you can find, and you realize that they fundamentally disagree. That some expert thinks that advertisement-based revenue model will win, and others think that transaction-based will win, or a flat rate will win, whatever. So you realize that there are uncertainties. And then you actually want to find the key uncertainties in number 5. and the key uncertainties are those which are big things. They are highly important big things, and they are uncertain. So you have things that change radically the future, but you don't know how. So you really want to find those where there is fundamental disagreement. And the most interesting uncertainties about the future are those where the experts genuinely, with emotion, disagree. So they have good arguments. They can sell convincingly 2 stories. They can sell you that this is the way things go, and the other one sells you the story that this is how it goes. Okay. Then you select the most important uncertainties, and you will come back to that with the example again. You choose those uncertainties to span the possible futures. This is the difficult phase, because what are the right uncertainties? You have a long list of uncertainties. What really are those you need? That's a challenging thing. Let's see how it goes. And then you go to debugging you check consistencies and so on of the scenarios, and then you can at step 9 you can go into quantitative modeling as well. This is in this particular version of the method that can be used, and system dynamics is one method that we have used for that purpose. Okay. Now we have this case. So we are jumping into a case, content delivery scenarios, and here the problem is the main question is that what are the alternative scenarios of heavy commercial content delivery over internet for next 10 years. So the time frame 10 years. This is about the internet, not about some other networks. Content focused, but not just about any kind of content. Heavy content, video and so on, which has a big impact on the network itself, capacities and architectures maybe, and then commercial. Not every content is commercial, so we want to focus on commercial content. Every word counts here, so you have to be very careful, because you can go, and you have to adjust this during your process, of course. Then supporting strategic questions which give guidance to what you are really interested in. And here we are interested in mobile operators. What is the role of, well, access operators in general, but especially mobile access operators or mobile operators. Actually, in this example, you have to be cautious, because this research is very IETF oriented. So we have tried to use IETF terminology. So we are using ISP, Internet Service Provider, and term, and mobile internet service provider, which equals to mobile operator. So you will see later on that when we talk about ISP, we actually mean mobile operator. And then specific question that comes from SAIL, this information-centric networking, ICN, or one specific incarnation called network of information out of that. What conditions for adoption could we find out? Okay, this is just some background information. You have been discussing in the last couple of days about these things. I don't go deeper into it. This actually just gives an idea of what architectural options there are. Content delivery networks, cloud, peer-to-peer, and then information-centric networking, which is a new thing. So the other 3 options here are more or less existing, and ICN is something new. And you can identify certain parameters: routing decisions, cache location, level of standardization, and content awareness, and so on. There are other parameters as well, but you can separate these with some key parameters, these architectures, from, let's say, techno-economic or strategic viewpoint. Now we are going through the recipe, the steps that I described earlier. So this is to identify the roles. You can see on the left-hand side, end user, content owner, content provider, internet service provider, which actually is the mobile operator here, cash operator, bank, and so on. I don't go into any details, but when you do this kind of scenario planning study, you have to pretty clearly define your terms, because these kind of role names are not so uniquely defined in general. So you have to define them. And it's very important to separate between the term role and actor. So the companies are actually actors. So or we can use the word stakeholders. You can see it somewhere here. Actors are the real business entities that make business. And the actors can pick up one or more roles. So the access operator actor can pick up the access operator's role, and that can be only that role. So then it's a pure access operator, or it can take some other roles here, advertisement aggregator role. So typically, if one actor is successful, it starts expanding somehow along the value chain and taking other roles. And basically, in this game that we are studying in this scenario planning exercise, it is pretty clear that we have two big powers here. We have the access operators, and we have the content providers or content aggregators. These are the two power poles, and the fundamental question is that on what conditions can these power centers of power expand and take other roles in the market. So this is more or less the underlying question. I don't go into the trends at all to save time. So this is a list of key uncertainties. We had lots of these, many more uncertainties, and gradually through a certain process we ended up into a shorter list. A short list, this is maybe already a short list, eight uncertainties. You can see the first one, mobile ISP, which means mobile operator bundling, that if the operator gets enough market power, the operator can start bundling things. So you can bundle the handset with the SIM card, and you can maybe bundle something else with the SIM card. You can even bundle content, and that actually means that you take more roles, and that means that you must have market power to do that. You might try to do it, but you don't succeed if you don't have enough market power. How you get market power, we'll come back to that later on. So there is a fundamental uncertainty whether the bundling strategy of mobile operators will succeed or not. In some countries it is very strong, but there are countries where it's extremely weak, and this is about the power game. Then content provider, the number 2 here, content provider revenue model. So there are strong signs of both advertisement-based revenue model and consumer-based revenue model, transaction or flat rate. And this actually represents a different value network. So who is paying? Is it the consumer who is paying, or is it the advertiser who is paying concrete money? There are of course then other ways to pay, not only money. So the consumers are giving something very important to advertisement aggregators like Google, as we all know. So we are kind of playing with our privacy, we are playing with our time, and we'll come a little bit back to that. So there is definitely tradables going on, immaterial tradables between you and Google when you use Google's services, even if you don't pay money. Then there are others. Content delivery control. Is it the content provider or the network side? Content provision aggregation. Is the content in general, is the world going towards more aggregation, big aggregators, or is it going back to more fragmentation? Cash ownership cache can be independent or bundled, and then it can be bundled to ISP or content provider. Independent cache means CDNs, so there are new players called content delivery networks who are focused on caching and some routing optimization, but who are not really the power centers of power. They are not content providers and they are not access operators. Okay, there are others, but through debates in this exercise, we ended up to pick U1 and U2, the first two on this list, as the key uncertainties. And in this debate, one thing that helps is this matrix, correlation matrix. So you can see the same uncertainties, number 1 to 8. And the question is that we are looking for independent uncertainties, independent variables. If there are dependencies, one is subordinate to another, they are not good for spanning possible futures. So we want independence. And you can see the green 0 means uncorrelated. So you can see that U1 and U2 are uncorrelated because there is 0 and the box is green. And there are other green options also here. So we don't get one and the only interesting choice through this exercise, but we can screen out quite many combinations already. So after this study, we only have, about 10 candidates, pairs of uncertainties left. So less than half of the starting point. And but then it comes back to let's say, good judgment to figure out which uncertainties help you best towards the research questions. And here I already mentioned these are the two ones that were picked in this exercise. And this, sorry about the small font here, I hope you can see it. Here you can see the scenarios. So you can see with the red, you can see the uncertainties, strong ISP bundling up and no ISP bundling down. And then on the left, consumer revenue, consumer-based revenue, which is a different value network and different revenue model compared to, on the right, the advertiser revenue. And so this is what we don't know about the future. We don't really know, and the experts don't know which way the world is going. And maybe at this point, it's good to mention how this relates to information-centric networking and to the caching. So using the scenarios, we are actually looking for who is deciding about the location of cache. When we know that, it's much easier to say where the cache might be located in the future. So the technical, or let's say that the business analysis is easier if you know whose business you are analyzing. So we are looking for the winners for each scenario here, the winning actors or the winning roles. And it's also probably at this point important to pick up the observation compared to some earlier talks here, and actually to the network of information technical architecture, because you can try to optimize the cache location and the cache functionality, all the technical parameters, by taking one or the other assumption as your fundamental assumption. And in network of information in SAIL, quite a strong fundamental assumption in most exercises is that you are not changing the value network. So you have your initial value network, and you, for instance, this means that you don't assume that the mobile operator, the access operator, would make business contracts with its content provider. And this is really fundamental. So you can kind of secretly build caches and optimize your own technical network setup. You can save costs, for instance. You can do caching to save your own, as an access operator, to save your transmission costs on interconnections. But that is not something that changes your business relationships with other players. If you make the assumption, you can change the setup fundamentally if you make the assumption that commercial heavy content, it's so valuable to the content owners that they want to control it quite accurately. They need to charge it for it. So you must have accounting information also for that information, those objects that are stored in a cache somewhere. So it's a fundamental requirement to have accounting information available, which means that you must have a feedback loop, which means that you must have a business contract between the access operator and the content provider or somebody else who can guarantee the accounting information and billing for at least for particular revenue models. The other fundamental requirement of content providers is that they need to be able to monitor the usage of their content and services. So they need to know every click that the end users are doing. Otherwise, they lose in the hyper competition between content providers. You know, for instance, that between Google and Yahoo or between Google and Microsoft Bing, the learning barrier is almost non-existent. If you know how to search keywords in Google, you can do it in Bing easily. And it doesn't cost anything. They are free services for you. At least you don't know that you are paying for with your privacy and so on. So, and it takes just a couple of seconds from you to switch from Google to Bing. And the switching cost in economic terms is practically zero. This means that the competition really is hyper competition, and the profits on that kind of hyper competition, according to economic theory, the profits are directly proportional to switching cost. So if you cannot block your customers and create some threshold that makes it more difficult for your customer to choose another vendor, then you are in a very low margin business. So you want to make it difficult to your customers to switch to competition. And in internet content businesses, it typically is very difficult to increase the switching cost, which means that the users have power, and this is a situation of hyper competition, which means that the content providers in their own competition against other content providers, they need to know every mouse click of their users to understand their behavior and needs and to compete against other content providers. Which means that if you put some stuff of this kind of content providers into a cache, you have to provide feedback about every click, mouse click. Which means that you typically must have a business contract, because you don't do this. It's very difficult actually to implement this kind of things on purely technical protocols that don't include any business flexibility, so to say. Okay, this was a kind of background for this study. So therefore we are interested in which are the scenarios and who are the winners of each scenario, because the winners have the market power to decide about caches and with whom to agree about caches. Okay, here we have the comfort buyer. It's typically, Elisa is a mobile operator in Finland, a national local mobile operator. And this probably would be good, this scenario for that kind of an actor. And comfort buyer takes the bundle. It's easier to take a bundle, and you take also the content in that bundle. So you buy everything from the access operator. Your life is simple. You're a comfort buyer. Then the other extreme here, if you take the demanding saver, which is probably Google's dream, this kind of consumer doesn't like ISP bundling, at least content doesn't or wants to get everything cheapest, and also doesn't want to give money or pay for content directly. Is ready to pay with privacy and personal information rather than money. So demanding saver, and then you can see the quality buyer and indifferent saver go the same way. Okay, now the names of these scenarios are chosen in a specific way. So these scenario names, comfort buyer and so on, they refer to decisions of consumers. So consumers have the ultimate power if we talk about market-based economy. And you can say that these are segments of consumers. Yes, but which segments really start dominating? So do we want to save money or do we want to be comfortable? This probably depends on the country also. On high standard of living countries, this goes slightly differently. But overall, we don't know, and these fundamental end user or consumer decisions, they create a competitive power that causes somehow these uncertainties to go in one way or the other. And when they go one way or the other, the consumer actually decides how the uncertainties will go, what scenarios will happen, and that will then dictate who are the winners. So consumers make the winners. This is a long list comparison between the scenarios, long list of parameters. I don't start going through all of this. Just the lowest line here, you can see the winning actor. There is some debate, for instance, in our paper, and we have had debates because, of course, it's not so. This is simplified. But it helps to understand and build stick figure models and encourages useful discussion and debate. So you can see that comfort buyer is good for local ISPs. Indifferent saver is good for global or, let's say, large ISPs, not necessary. Well, global means more like large players who can invest and compete, for instance, on the advertisement aggregation market. And then quality buyer, it will be the payment-based content providers, and demanding saver more towards advertising content providers. And then if you take the kind of final step, you combine what we have been discussing. You can see that there is one on the left-hand side. There is one winner. We can debate how clear that winner is, but one winner for each scenario. So we actually have winners, which is the same as we could actually have two columns here to also show the scenarios, but in this picture there's more space for other information. So, and then you have the different architectures, and according to this kind of analysis, you can see that the big ISPs are most likely to go for information-centric networking. This is a very rough description, of course, purely qualitative and so on, but based on expert views on different things, and then combining the expert views. And but you can also, if we have the fundamental question that ICN, information-centric networking, or network of information, how probable it is in each scenario. So these content players are not so interested based on this logic. And there is a challenge if we look for fundamental changes, we should somehow look for a win-win. Those things typically happen on the market that somehow create some win-win. And the challenge here is to create win-win between ISPs and content providers, clearly. Yeah. It's only good for the global ISP? Yeah, well, local ISP also, depending on local ISP has less investment resources, a small ISP, but also for that there are debate on whether it's be medium or high. But the local ISPs are not really in the global game, and they don't have the market power internationally. So therefore, pushing it through and having it, it's more likely if the global ISPs are in the game. So this is the last slide of this scenario planning method. Any other questions on this one before we move ahead?
One question. As you try to study how cloud networking could have an impact on how ICN could be deployed?
That we have debated a lot, and that certainly has. I think also in this study we started with network caching, and we actually realized that we need to expand to clouds. So that was an observation during the debates that, okay, we cannot keep clouds out of this. And the difference between clouds and CDNs or let's say more in-network caching is the complexity of data. So if you have complex content, which includes processing, you need databases, specific application software and so on, then it is more likely that it's more difficult to distribute that function. Then you need some kind of advanced data centers, and cloud is probably of course cloud is a unclear term, but also you need to define it for every discussion separately. But yes, I think that's a very good observation. The cloud is fundamentally important, and it comes back to the business case. So it clearly is needed for complex content. The cloud is strong for complex content, but it's more expensive also. So when you go to in-network caching, you can reduce costs, and the economy of scale works. Technically, the cloud would be good also. I mean, it's feasible technically, but the cost is higher. So you might need. There seems to be a business opportunity for simple caching between the clouds and no caching. But that's a very good question. Any other questions? Okay, so let's move to value network configuration method. There is actually, we had some collaboration with MIT people. They actually did earlier something similar as these value network configurations, and this is something that goes closer to system dynamics, which I will hopefully there's time to touch that also later on. So it's a way to give some structure to what we have been talking. So if you think about the scenarios, they are still quite unstructured and weak and qualitative. But if you use some notation like this value network configuration, you can start going a little bit deeper and discuss more explicitly about certain things. So this is about terminology. The first thing here is to separate between technical architecture and industry architecture. There are other terms used also. The industry architecture is sometimes called market architecture or industry structure, depending on how big business we are talking about, how big market. If we talk about small new startup type of services, then we talk about value networks. So you have to be very cautious with the terminology because it's not stable and it's not really law of nature type of facts. But essentially, the market works based on two things: the distributed technical architecture, which means that there are nodes and there are some protocols between these nodes. That's the technical architecture. So there are some transactions, protocol transactions happening. The protocol itself is predefined, typically quite well predefined, and then the actual transactions happen using that protocol. And if we take the technical architecture, as opposed to the technical architecture, we take the industry architecture. There we have business actors that can be end users or companies, let's say legal actors, and they make business. and there is typically the same fundamental components there. There is a business contract, which is pretty static, and it is predefined. It is actually, there is also that for you and Google. If you just typically don't read it, but there is a business contract when you check that small box and you skip reading the long text that Google lawyers have done. You actually sign a business contract, and it very accurately defines what are the roles and responsibilities and so on. So you definitely do business contracts with Google, and then you do after you have the business contract, which is very similar to a protocol. It defines exactly what you can do in the future. Then you just do transactions based on that contract. You type a Google search, and that's one business transaction based on your business contract. But then with Google, you also have you have your browser, and you have a certain HTTP protocol technically. So you have the same world technically and business-wise, the same abstract components. And the question is that how do these relate to each other? And when is the technical architecture driving the industry architecture, and when is it the other way around? When is the industry structure driving the technical architecture? It's a chicken and egg question, and they evolve hand in hand. And this is actually I'm pretty excited about this path of research because actually communications, understanding the technical interfaces and business interfaces. Technical interfaces, the protocol and transactions. Business interfaces, the contract and transactions. Understanding these two actually is spreading. We have this Internet of Things. So there is processing power coming to more and more things. And everything links a technical interface and a business interface. And you have to understand this kind of thinking well to be useful in planning the business in that kind of environment. And actually people who have protocol background and distributed systems background have very good competencies to understand not only the telecommunications and the information part, but also the other sectors of industry where this digitalization is moving to, and there is a lot of need for this kind of understanding that we are discussing here. This is just a notation, but understanding the dynamics, underlying dynamics is quite important in my understanding. Here we have the difference between actor and role. And as you can see, there is certain notation. There is business interface, the black arrow, and the technical interface, the red arrow. And then we have the round or almost round circle there. That is a technical component, part of the technical architecture. So it's one node in a distributed technical architecture. And then we have a business role, which is the dashed box. Business role, and then we have the actor, which is the solid box. And one actor can take multiple roles. And each role is typically quite hardwired to a technical component. If you want to be an access network provider, it's very difficult to do it if you don't have an access network as a technical component. So you need to have that. Okay, and you have to be accurate. The red arrows here, they link technical components. So there is the technical architecture based on red arrows and round and the circles. And then there is the business architecture based on black arrows and black squares. So we are actually using a transposition or superposition, putting the technical architecture and the business architecture one on top of the other. Okay, here we have one research question. Let's say, this is just an example of how to use the notation. Value network configurations for information-centric networking. There's some background information here, but let's not stick in here. So this is the roles. This is the roles, and you don't see the business interfaces. There are no red arrows in this picture. You can see the notation on the right-hand side. This mainly lists the key roles. They could be just a table, but here they are already in some structure, because you will see several slides of value network configurations related to this same technical component soon. And you will see that the technical components keep their position on the slide, which makes it easier to read. And here you can see, okay, interconnectivity provider, access network provider, end user in the lower row. And they actually, there you can see the actors. There's also content provider. They are the existing actors that we know quite well. But then in information-centric networking, we have new technical structures. And we have the roles here. So we have the cache management left up, and then we have cache location ownership and building space, content network management in the middle, and name resolution. They don't have any actor yet here. So you don't see any actors. So they are floating free. They are roles, new roles that are floating free, because nobody in the real market has taken them up, because this is a new situation. So the question here is that what kind of Lego kind of allocations, Lego game allocations can we figure out here for these functionalities? Okay, this is again about key roles, but let's not stick here. So this is the first case, access network provider, A and B, access network provider driven pure ICN. And I have used here the yellow color to make it easier to see the access network provider role. So here the access network provider is the strong player, and has taken the cache, all the cache functionality roles. All the new roles would in this case go to the access network provider. Here you can see a certain setup of roles and technical components linked with the technical interfaces. Okay, there's some analysis of related to this same case one. You can see the benefits for the access network operator. First bullet is savings in interconnection costs, and strategic dependency on transit provider decreased, and to make agreements with different content providers about caching. And this challenge, you have two ways to solve this problem. One is that you consider that the challenge is too big. You forget business interfaces. You don't even assume that business contracts would be done. So you focus on the technical caching, and you develop your caching architecture so that it does not assume or depend on content providers' business decisions. But that limits your opportunity. Then you cannot expand your business and so on. In the previous scenario planning exercise, we made the opposite assumption, that the access network provider has a powerful position in some scenarios, so that he can make business contracts with content providers. That's a complex thing to arrange. It's easier for big ISPs, because they have the volume and the power to discuss with content providers. More difficult the small ones. And this further describes the same case. So access network provider driven, pure ICN, but this is a dynamic picture. So here you can see that the technical interfaces and business interfaces are opened Actually, the notation, you can see the notation here. The intangible benefits red is identified separately, and there are payments using black arrows and service and product interactions with blue. So this goes deeper. It's not just saying that what are the technical interfaces, what are the business interfaces. It tries to tell something about the dynamics. You should get the next level of abstraction on what is happening between these different roles here.
Sorry, can
Yeah.
you mentioned before that in this case, an end user would allow the access network operator to tell some personal statistics to the content provider, right? Otherwise, you wouldn't be able to have this red arrow between access network operator and content provider.
Yeah. Yeah. So.
The question is this something that the end user would be aware of? Because actually the end user is the right side of the slide. And then the access network operator is giving these non-tangible, intangible benefits to the content provider in terms of user statistics. I assume that you would be giving up, like, I don't know, how many people are connected to certain access point or something like that. So this is kind of what we have been calling content for a while. And the content provider is true that it can do a lot of things with this type of information. But my question is the end user aware that this information is being disclosed to the content provider?
Of course, this picture doesn't tell about that, but it's a fundamental question that and that is a problem, because if you think about Google, for instance, so there are lots of assumptions that Google is storing a lot more information about users than what they are telling they are doing, and the same applies to any big content providers, and even Apple's that are not really content providers, but who are managing end user data. Google, Apple, Microsoft, Nokia, and so on. So all these, they actually make contracts. If you read the small print and when you check the box without reading, yeah. But there are interesting things. They for instance say there that one important question is that are they allowed to give out some information to other players? And this comes back to advertisement about, for instance, advertisement and so on. But it's much easier to handle this kind of sensitive, privacy-sensitive information if it remains within one player. And this is a big strength of Google's and others. And this is a fundamental problem for caching. If you separate caching, and you should still be able to deliver that information to the content provider, you get problems with lawyers. And probably the first assumption is that the information is a lot less detailed about the usage and users. Still, the ownership of users and there is, of course, content providers have more information about users anyway, because they have direct interactions and they have their own application level interaction happening. But that's a good comment. These are the challenges that the network of information, NetInf, has. That how to get into the level of business contracts and solve the privacy issues and so on. Okay. Yeah.
There is something that it seems to me missing in this model, but maybe it's not missing, I just don't see it, is related to the cooperations between the different players. For example, you were mentioning Google, and they are currently exploiting user knowledge, and they try a lot to avoid that other actors, other players, can access this information by using HTTPS.
Yeah.
So, which basically is going to be harmful for cacheability.
Yeah.
And they sell this to users as a mean to protect their privacy, while it's just a way to avoid network operators to cache their content, especially, and which actually is not improving the privacy of the users. It's just improving the business model of Google. And so the question is this kind of modeling able to take into account this kind of
well, this
level of cooperation? Because
yeah,
here you have seen kind of level of cooperation.
yes,
As you have man moving
yeah,
cooperation.
yeah. I don't have this in this slide set. I don't really have the any special focus on intangible benefits, but there is additional notation that covers, in my opinion, quite well these intangibles, and they are typically divided in three components. There is actually attention. So what Google gets from users, for instance, instead of money, is attention, information, and loyalty. And in that type of notation, which I don't have here, it's just simple additions here. You can also follow the links that information, when information about users, which is privacy sensitive, moves to whoever, like Google or somebody else, then you can, if you know enough about the business contracts and what happens between the companies, you can then draw the links so that you can see where the information flows. And the notation supports that. So, of course, notation doesn't solve any problems. It just makes it easier to describe and debate about that. But yes, the answer is that yes, there is that kind of notation that supports those components, and it really comes back to separating still. This is again not law of nature, but a very useful division is these three components of intangible benefits, and if you add those, you can see that it's clear there is no free lunch, that it's really hard business that is happening between the user, and that's actually interesting because it's public. When we have tried to find the business contracts, it's easiest to find the business contracts between consumers and the internet content players like Google, because they are public. It is that small print. So you can study that and you can make interesting observations. But if you want to get the business contract between Google and, let's say, Vodafone, it's difficult. It's not accessible to many people. We have tried all kinds of tricks in Finland to get the visibility to those business contracts, but it's more difficult. So we don't exactly know because they are secret contracts. But then what comes to this more fundamental question about who knows what about consumers, that is really intriguing. And we are doing something which is not here on these slides, but in Finland we are actually collecting data from networks. So we are arranging panels where we collect accurate transaction data on everything that users do on mobile devices. That's of course small panels, hundreds of users, but we get everything they do with their handsets. And they know about it. They agree to do that. So and then we collect TCP/IP traffic traces and some radius data from mobile operators' networks to understand the traffic behavior. And then we have some content providers, big media house in Finland, biggest in Nordic countries, and we analyze the data from the server side. And we are analyzing the pros and cons from the power game viewpoint. It seemed to me 2-3 years ago that the mobile operators are in big trouble in this game because the content providers and handset platform houses like Apple, Microsoft, Nokia, Google, that they can collect all kinds of information, but the mobile operator cannot. But now the processing power and maybe the processes of mobile operators have been evolving so that actually all interesting data goes through the access especially mobile operator, because there is the kind of central points where you can capture basically all traffic of a single user. So that's very specific, and big opportunity, but there are legal limits and processing power limits and cost limits. But in these comparisons, the access operator's position seems to be improving. But what we have seen also the problem that HTTPS and encryption, and that seems to be increasing, and it hits our analysis as well. So there are black areas which we don't see because of what is happening there. And part of that might be for privacy, but the real concern of end users. But there is indication that some of that is happening just to make life more difficult for competition. And I think you are right if you refer to this. Yes, it seems to be happening, and but whether it's legal, whether it should be legal, and what are the implications, that's very interesting.
Another remark. You are mentioning mobile network, and all this model is based on some form of asymmetry in information every player has.
Mm.
And mobile network is an interesting architecture because, for example, consider 4G LTE infrastructure. That is, I think, to the best of my knowledge, is the only infrastructure where DPI is standardized.
Yeah.
So where the mobile is a very centralized
Yeah.
infrastructure, especially for security and dealing, intrinsically centralized for these two main reasons. And there, the fact that DPI is standardized is in 3GP, so it's necessary. It's, I think, very much related to what is presented.
Yeah.
So the fact that you really need the access network to be aware of what's going on.
Yeah.
Because otherwise you are completely out of the value chain.
Yeah. But this is a very interesting evolution. It seems that information about end users' behavior is accumulating more and more in different places in the network. Something is in devices, something in network, and something in servers, data centers, and the question that what will be the business power, the business opportunity for that accumulating data, which roles and which type of actors will be most capable of exploiting that information for various purposes. This seems to be a growing factor and growing force that is becoming more and more important. So extremely interesting to study. Yes?
This figure assumes that you have an open internet structure. It is possible where the end user take a payment which is free of charge, and I have an IMS infrastructure that the user is completely hidden for the content provider.
Yeah, there are different versions. So you can use these notations for describing different setups, and the extreme situation where the access network operator has big power, that is probably Docomo in Japan with iMode, because that originally the user profiles and all the charging and information about subscribers was held in the mobile operator's network, and actually the interface between content providers, which made a contract with Docomo, that interface was defined technically so that the user's identification is scrambled, so that, for instance, if you sell music to users, you cannot identify the users, so they are totally incognito to content providers, and that just means that the market power for mobile operator in that case is extremely large, and that was probably not well understood in Europe, for instance, in the early days of iMode, because there were even some IETF gurus were admiring the open internet of Japan and the mobile internet. But I remember some discussions when some of these IETF experts came back from Japan, that they actually were pretty sad and realized that this was not exactly the open internet, even if the protocols of IETF were quite heavily used.
Is there something in regulation for this kind
That's a good question. That's a good question. It is probably not so explicit because in Europe that problem has not appeared in a strong way. I think that it would have come up more visibly and most likely the regulators would have done something. But in my knowledge, the situation has never been like in Japan. So Japan is very vertically oriented market, as we all know. So, okay, let's see if I can still squeeze something here. This is I have many different setups for the same environment, and I don't go through. I just show the notation of how you can roughly use it. All the time I'm using the yellow color for access network provider, actor called access network provider, who can take more or less roles in the technical architecture. This is a little bit smaller setup here when we have virtual CDN value network configuration. Then if we move to pure play CDN, then the access network provider is even smaller in number of key roles. By the way, one thing that I forgot to mention, this seems simple to draw this kind of pictures, that you just kind of use a suitable editor. But it is highly challenging to figure out that what are the relevant technical components, because you can pick up higher level components, or you can go more in detail. So you have to zoom in and zoom out and figure out what makes sense. For instance, you typically focus on the first tier value network roles. You're not interested in the subcontractors. Like in these cases, there are handset vendors and network equipment vendors that are important for operators, but they are not relevant in this picture. We are talking about the services aspect here. But also in services, there are all kinds of subcontractor type of things that are not relevant for the actual key power play. So you have to limit business-wise your scope and the level of abstraction, and you have to limit or define the technical level of abstraction on the right level. If you go too much on detail, you lose the glue, or if you abstract too high, you are out of the game again. So look simple, but try to do it, and you will be desperate soon. Okay, so for example 4, this is an interconnectivity provider, CDN. Access network provider is very limited in this scenario, or this value network configuration here. Content provider, CDN. This is Google's type of scenario. And peer-to-peer value network configuration. End users are taking a huge part of the cake, so to say. This was discussed, by the way, in our scenario planning, this peer-to-peer, but the conclusion regarding commercial content, heavy commercial content, is that the laws and regulations will be moving towards the direction that the illegal aspect of content is diminishing and not a big factor in the future. So somebody might think that it's a big factor, but in this exercise we didn't need to focus on peer-to-peer. Content provider, just to list examples. I guess we are out of time here, so I'll skip the rest of the slides.